Hey, this is Joe, graybenchelec. Welcome and welcome back. Today on the bench for repair, we have a vintage MXR Distortion Plus. All right, so we got this old MXR Distortion Plus. It's got the script logo. I believe these are from the middle to late 70s, and then they changed over to the block logo that's more modern. I've already tried this pedal out in the practice amp I have. There's absolutely no output. It does, the bypass does work, so the switch is probably fine. However, when you engage the pedal, there's no output, no response from either potentiometer. Input and output jacks do seem a little bit corroded, so we'll try and clean those up a little bit. Pedal's a little bit dirty all around, but it is 50 plus years old, so to be expected. The MXR Distortion Plus is a very simple circuit, and so we have the schematic here, and we also have a layout of the PCB inside the pedal, at least what should be inside the pedal. Just quickly going over the schematic since we have it right here. We've got our input. They'll normally be going to the switch, but that isn't shown in the schematic, that's fine. Input, we go through a 1 nanofarad cap that'll roll off some high-end, like radio frequency extra stuff. 10 nanofarad input cap to keep DC off the guitar pickups, assuming that's what's plugging in first. 10K current limiting resistor, 1 meg bias resistor, which is coming over here for that half supply from the power supply. That's biasing the op amp. Op amp is set up as a very simple voltage gain setup here. We have our 1 meg resistor here in the feedback loop, which is going to give us that voltage gain. We also have the filter string coming off here with a 47 nanofarad cap, a 4.7K resistor, and the distortion control. 1 microfarad output cap from the op amp, another 10K resistor, and then we have our clipping diodes. Hard clipping diodes, 1N34A are just generally germanium diodes, along with a 1 nanofarad cap to ground to roll off some more high end, and then a 10K output potentiometer going then to the switch and then to the output jack. Power supply over here is a 1 microfarad filter cap and the 2 1 meg resistors, creating that 4.5 volt half voltage supply to bias up the op amp. So let's go ahead and crack open the pedal, see what we see inside. All right, inside the pedal here we can see we got some of that old foam that basically just turns to dust as soon as you touch it. So I'm just gonna scrape this out of here. It's probably a good idea not to breathe this. So I'm gonna put on a mask and come back when it's all cleaned off here. All right, so I got the enclosure pretty much cleaned up here, got all the foam off the back door here, and also did my best to clean up the PCB here of the foam, or what was remnants of the foam. There's a good bit of corrosion on the jacks, so I want to see if I can take care of that a little bit. One trick is, well, first off, I'm going to try and protect the PCB here. I'm just going to throw that in a little plastic bag just to try and protect it from the deoxit I'm going to shoot into the potentiometers. So first off, we're just going to hit those potentiometers with a little bit of deoxit. Here, deoxit, spray inside the potentiometer. All right, turn it over, turn the knobs back and forth, work that deoxit in. Just going to clean up the copper trace or the carbon traces on the potentiometer, and hopefully rejuvenate the little bit of lubricant that comes stock from the factory. All right, that's feeling good. No idea if their spots were noisy because we didn't even get that far, but hopefully if it was, the deoxit cleaned that up a little bit. Speaking of the potentiometers, they are dated there. You can see they're MXR marked pots, and they are dated the 24th week of 1975, and 137 is the EIA code for CTS. Over here, it is the 47th week of 1975, also CTS, also MXR marked pots. On the output jack here, you can hopefully see there's a little bit of corrosion on the sleeve there. You just take a soft adhesive pad, like a Brillo pad here, just kind of come in here and clean that up a bit. The outside, it doesn't really have anything to do with the electrical connection. So this is more just looks. I'm not gonna go crazy on this because it's a vintage pedal. It should have some patina on it, but just enough that it's not excessive. Also for the inside, there's a bit of corrosion as well. And so you can take that same Brillo pad and cut a strip of it out and twist it up, and take this inside, stuff that in there, give it a spin. This is an electrical connection. This is the ground connection from patch cable to patch cable, or pedal to pedal, or your output cable to the amplifier. So this is an important connection. You want to clean this up, like so. Blow the dust out of that a little bit. You can also take a 1/4 inch jack, whatever, and spray that with a little bit of deoxit, just on the jack itself. And then just take that and run it in and out of the jack a bunch of times. We'll do the same thing for the input jack. So hopefully that bought us some fresh metal on those 1/4 inch jacks. I think now we're ready to start actually figuring out why this pedal isn't making any sound. So first off, let's just do a quick DC voltage check. Let's throw a 9-volt battery in the pedal. 9-volt internal battery only. There's no DC jack on the pedal. So we'll install that battery here. One thing I don't like is the PCB just kind of floating inside the pedal. There's no protection to the top of the enclosure except for that foam that used to be there, which is disintegrated and gone now. And it seems that there never was any protection from the bottom of the PCB to the components inside the pedal. So I think what we might do is something similar to what Boss does, which is put a piece of something in there. I have some Bristol paper that's sort of like heavy construction paper. I'll just cut a couple pieces that are the right size, and we'll just slip one on top, one underneath, and that should at least just, if nothing else, make me feel better that there won't be a direct possible connection between either the top of the pots or the connections on the input jack or to the top of the enclosure. But anyway, let's go ahead and see if we have voltages. According to our schematic, we should have 9 volts coming in, so let's check where that is. So this red wire here is from the battery terminal, so that's this connection. And that's coming up here to, what is that, pin 7. We can confirm that on our schematic here. And yes, pin 7 connects to the 9 volt. So on our op amp here, this should be pin 7. And yes, we have 9 volts there. Schematic says ground is pin 4. So we can check for that. Should be here. If it's not clear, the op amp is upside down. And yes, pin 4 has ground connection, which is good. We can look here. We see we should have 4.5 volts, and that'll be connected to pin 3. Yeah, it's at 4 volts, which is probably one of those resistors drifted. So this is the layout from Electrosmash. I found this on Electrosmash's MXR Distortion Plus article. So that's where this is from. So shout out to Electrosmash. I'll put links to that article that goes over how the MXR Distortion Plus works if you want to check that out. So the voltage comes in here, connects directly to pin 7 like we just tested, and that's working good. Here are the 1 meg and then the 1 meg right here. These are the 2 resistors in the power supply that give us our half voltage. And then here's the 1 meg bias resistor. So matching that up to the schematic, we have the 2 1 megs over here that are creating the half voltage, and here's the 1 meg bias resistor. So we can see that 1 meg bias resistor is coming up and it's attaching to pin 3. And yeah, we're seeing 4 volts there. So that should be here as well. There's that 4 volts. It's actually pretty well matched here at the junction between the 2 1 megs. So that half a volt's dropping over that 1 meg resistor, which is fine. It'll work at 4 volts, it'll work at 4.5, that's fine. So our op amp has bias and it has proper power connections. And that's basically all the power connections for the amplifier. That's the only active component. All right, so I think next step, we know that the op amp is receiving power as it should. So let's go ahead and inject a signal from an oscilloscope and see where the signal dies out. All right, so we got the oscilloscope hooked up here. We have our wave generator plugged into the input here. Wave generator is spitting out a sine wave at 1 kilohertz at an amplitude of 200 millivolts. So we can start with the input. That is this connection here. That's coming down to the 1 nanofarad, which is connected to ground, and then 10 nanofarad input cap, and then over to the 10K, so we can check all that stuff. So here is the 1 nanofarad to ground, and then yeah, we can see our sine wave there on the screen. That's good. And that's coming over here to the 10K. All right, so our sine wave input signal is making it that far. Obviously through the 10K should be fine. There's the 1 meg bias resistor. Still, if I can hold the probe steady, no problem there. And then coming over here to pin 3. Yep, pin 3, we can still see that sine wave's coming in. It's not triggering well on my scope, but it is there, that's good. And then coming out of the op amp, so we'll see it comes out on pin 6, so we should also see that sine wave there. And if we touch pin 6, we get nothing. So we should see not only a sine wave there, but depending on the condition of the distortion, it should be larger, but either way it should be larger because we have a 1 meg resistor in our feedback loop, which is going to give us voltage gain, but we're getting nothing. So we have input signal coming in on pin 3, as we should. There's our sine wave. And then on the output of the op amp, which is double checking, is pin 6. So that's 876 right there. There's nothing. So we know that our op amp is getting power, and we see the signal going into the op amp, but nothing's coming out. That's pretty definitive proof that the op amp itself has a problem. So the next step is going to be pulling that sucker out and putting in a replacement. All right, so we got that original National Semiconductor LM471 or 741 pulled out of the PCB here. As far as a replacement, I have a decent number of LM471s or 741s. I don't have anything as old as 75. I also don't have either many or maybe none at all National Semiconductor, but I do have these Motorola ones from 1983. They're marked 8310, so 10th week of 1983. But Motorola is a respectable company. These look pretty old, so they kind of look the part. We'll throw this Motorola chip in here and we'll see what happens. All right, so now that new Motorola chip is installed, let's go ahead and check the pedal again to see if we're getting output from that op amp. So again, we have the signal coming in on pin 3, and now on pin 6. Oh yeah, there's our output. Let's turn that down. There is our output sine wave. And you can see there we're getting a little bit of clipping on the down going. That's probably the slightly off bias, the 4-volt bias. So we're not getting equal up and down swing from the op amp, but we have output, which is great, and our output is approximately 2.5 volts, so 5 volts peak to peak. And then if we want to look at the output from the pedal up here at this 10K, so here's our output connection to the potentiometer, pin 6 through the output cap here, and then up to the 10K. So at this 10K should be our, yeah, right there. Because this is where, not this side, but this side this is where it connects to those clipping diodes, so this is where it's going to be clipped. Actually, we can just look at the clipping diodes themselves and break that a little bit bigger. You can see those diodes are really clamping down on the voltage. But there, so there you can see the diodes are clipping the output signal, and it's symmetrical. It's clipping both sides about the same. And of course, if we run that again, we can see at the output, yeah, right there. So we can see that go up and down with the output potentiometer. That's your volume control right there. So at least from what the oscilloscope is telling us here, we do have a functional pedal. We have signal going all the way through. It looks like it's clipping like a distortion pedal would be clipping the signal. So let's throw it into an amplifier and see what kind of sound it makes. right, I hope you enjoyed watching the repair on this vintage MXR Distortion Plus. If you have any questions, feel free to leave them in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. I'm Joe from Graybench Electronics. Thanks for watching.